let's get started, everyone. We are going to have, I don't know exactly for how long, but 2-3 hours, depending how it goes. And about that training, so I give like a rough overview about the KDE stack and what you can find in there and what you can use to actually make applications. First thing, so why am I doing this? Who am I? So I started to use KDE a long time ago now, and yeah, I had a modem back then and so on. And I downloaded during the night and compiled during the day. That's pretty much what I did. I didn't contribute immediately though. And so I started to contribute like 20 years ago, roughly. And I love the community and how I got quickly accepted in it. And so I kept doing things. In particular, I worked quite a bit on KDE Libs and on the change from the KDE Libs model to the KDE Frameworks architecture that we have now, which explains in part why I'm doing this. And I also helped with setting up the KDE manifesto. And lately, even though that's a bit on pause, but I would like to resume that, I've been looking at the community, the data produced by the community, and see which patterns we can find in that and so on. So that's spare time. On my work time, I'm working for Enyoka Haute Couture, which is a small consultancy. So we are doing software projects for customers, but we're also providing expertise. We're also teaching people and coaching people. And I'm doing that still from where I studied, which is in Toulouse. All right, so the goals for today, that's to have general knowledge of the KDE stack. And because of that, there will be some parts of that training where it will be about high-level details so that you can have like an overarching picture of how it is. There will be some code displayed though. The idea is also to have an idea of how extensive it all is. I won't be able to be exhaustive though. If we want to cover everything which is available in frameworks or every little details about Plasma sessions and so on, that would take days and probably be pointless. At some point, you just need to experiment and try by yourself. But we try to cover what I consider at least, so it will be BPS, obviously, most important or pervasive pieces. And the big bias in that particular training is to get an idea of the integration points between all those pieces. That means for those, we will have to go at lower levels than just the overall picture I was mentioning earlier. I like to give this kind of picture because we try to have everything which is kind of independent, but at the same time, if you're using a KDE session with KDE applications, there's a feel of everything being integrated. So obviously there's something which happens behind the scene, and that's what I would try to give you an idea of during that training. Big disclaimer here, your head might spin because that's a lot of content obviously to cover, and you might not absorb it all in one go. Please feel free to ask questions along the way before you feel lost. So I keep the chat open on the side, so I will keep an eye from time to time. So if there's some chatter there, I should be able to answer questions. As a second disclaimer, maybe for this one, it grew a bit over time. And lately I'm thinking that at places it feels like two trainings screaming to get independent from each other. So it might be one of the last times I do it in that format, and I might actually split it in two different trainings later on. One more focused on the application and developer experience story for that side, and one more for the integrations and how the session works. All right, let's get started with some history. In that section, our objective will be to have a refresh on some of the basic things we get from Qt. So I will talk a tiny bit about signals and slots, but very briefly. It's not a Qt training. We want also to have an idea of the very complex history of our stack and to identify the defining parts of that stack. And we want to get a better feel of the relationship between Qt and KDE on a technical level and a non-technical level. And we also have a first approach of how our products fit together. So the very early days, that's 28, that's something like that, years ago, Matthias Petrier, who announced on the mailing list the cool desktop environment. And so, yeah, it was cool with a K, so that's probably because we're Germans, I guess. They dropped the cool part very, very quickly because they realized it was, I don't know, kind of weird, maybe. And so it quickly became the K desktop environment. Back then, in the initial email, you can see that they already identified Qt as being something with a lot of potential and needed to use. And they quickly, in a month, had the first version of the KDE libs. Just before Christmas, they had the first window manager. They had kpanel back then, the file manager. So a few components which starts to look like a proper desktop. February the next year, there's the KDE Free Qt Foundation, which has been created, which if you've been following the news, we try to actually mention a bit more often than we did in the past. The first big talk about KDE that was at Linux Congress in May, just after it started. It's actually a funny story somehow. So they did that talk, and there was supposed to be another talk just after that about some Office suite, which is long disappeared now, I think. And the people after, they were so disgusted about what Matthias just presented that they basically just skipped and didn't present. And then in August, there's actually the first paper in a German journal. Then we get a series of meetings and beta versions. So there's the KDE 1 meeting in August, and then a beta 1, a beta 2 in December. So we're a bit more than a year after the creation of KDE itself. The KDE EV is founded. Interesting fact that you might have noticed at that point, if I go back one slide, the KDE Free Qt Foundation has actually been created before the KDE EV, which is interesting because very often people think that's the other way around. We'll get back to that particular point a bit later. A couple more betas, and in 1998, the first stable release of KDE. Back then, the definition was KDE is a network transparent contemporary desktop environment for Unix workstations. KDE seeks to fill the need for an easy-to-use desktop for Unix workstations, similar to the desktop environments found under the macOS or Windows 95 NT. We believe that the Unix operating system is the best operating system available today. So the parts in bold, that's actually me who did put them in bold, because I think there are important words there. So that the first definition of what KDE was back then, and interestingly, we find the easy to use, we find the network transparent, contemporary, and Unix being important. And we still live by all of this today, which I find like something amazing. To 28 years later, we are still actually fulfilling that particular vision. And so for KDE1, there's a couple of there's a couple of technologies which were there. One of them being open parts, which is long forgotten because it's not there anymore, which was based on Corba. So for the youngest amongst us, Corba was a very heavy enterprisey technology for having components interacting across processes. And it was kind of heavyweight, which is why one of the efforts during the KDE2 meeting, even though there was no KDE2, right? So those meeting names were very confusing back then. The KDE2 meeting, one of the goals was to move away from Corba. So they created something that they called Canosa, and they changed the name fairly quickly, and that's actually what would become KParts. And during that same meeting, so Matthias Ettrich and Preston Brown, they got drunk together, and they think that they can write an ORB in one night. So that's a very important part of what was Corba. That's the object request broker, which allowed actually objects to call each other over kind of a bus. And so they claim they can do that in one night, and the result is DCOP, DCOP being the ancestor of dbus, basically. So they were actually right. It was probably buggy still back then, I guess, but that got fixed later on. Then they got a third meeting, which they called the KDE3 beta meeting, which has nothing to do with a KDE3 beta, because that was about getting KDE 2.0 out of the door, which they managed to do in 2000. When that one is released, there's the actual availability of DCOP, KParts, KIO. Okay, that's three important technologies inside of the KDE stack, and they really got established for that particular version. So in a way, the versions we see today have more in common with KDE2 than they have in common with KDE1. Right? There's clearly a big shift between 1 and 2 there. Then we get to the road to KDE3, where there's an actual KDE3 meeting. And then we get to the release of 3.0. Another meeting where I finally lose the habit of those weird named meetings. And so they start calling it Castle. That's actually around that time that I started to contribute, even though I didn't attend. I was following things and discussions over IRC back then. Then we have a whole series of 3.1.2 and so on. That's actually one of the very successful releases of the KDE community. A few academies in between, the first one being in 2004, and that's when the meetings all become academies, right? And we don't change the name anymore, even though we changed the capitalization, but we love to uppercase the Ks back then. And so then we get to the 10 years of KDE, and 2008 we have KDE 4.0, which is another important one because that's when we switched from DCOP to dbus. Right? Between KDE 3 and KDE 4, there's been a lot of effort to actually make something equivalent to DCOP, but independent from Qt, so that it could be reused by people who don't necessarily want to depend on Qt. And that was a hard dependency for DCOP. Hence how dbus was born, and it was a clear collaboration between KDE and GNOME people there. On 4.0, that's when we get Plasma, Phonon, Solid, Threadweaver. So there's like a whole series of new frameworks appearing for 4.0, and that's where we get really close to what we have nowadays. A few more academies, one in Belgium with lots of drunk people, because Belgian beers are actually a trap. And the first desktop summit in Gran Canaria, there's been actually only 2 of those, but that was a joint GUADEC and Academy. And that's around that same year that we started to rebrand KDE. and to position KDE not as the name of the software anymore, but the name of the community producing the software. We got, for some reason, an academy in Finland, and also for some reason, some push for KDE Mobile. If you remember, that's around the time that Nokia was actually doing things with Qt, so that's not actually random. Then I fast forward for KDE Frameworks, and so KDE Frameworks 5 and 6. That cycle actually started in 2011 now. We had a meeting in Randa, which is a very small village in the Swiss Alps. We basically locked up lots of KDE contributors in the same cabin, and we made a plan to actually change KDE Libs into something that we would call KDE Frameworks with more independent libraries. The second desktop summit happening around there, and the mobile initiatives led to the KDE4-based Plasma Active, Plasma Active stack, and there's been like a Contact Touch version, a Calligra Active version, to try to get things to work on mobile and tablets. There's been more academies, obviously. So the plans for framework started in 2011, but that actually delivered only in 2014 for KDE Frameworks 5.0. Quickly followed by Plasma 5.0, and also the next year, the announcement for Plasma Mobile, which are still around. And then almost 10 years later, we started the 6, so KDE Framework 6 and Plasma 6 cycle. This training will focus mostly on the stack at that stage of evolution. Okay, so on the 6, KDE Framework 6 and Plasma 6 version. Now, in parallel to that, there's also the history of Qt. Qt actually started a few years before KDE, so in 1991, by 2 master students in Norway. And basically, they did their master thesis based on the ideas of seeing how you could have a graphical toolkit with an event loop and a signal slots mechanism. So that was already in there. They incorporated Trolltech at the time in Oslo, and they made their first Qt sale a couple of years later, which was to the European Space Agency, which is not too shabby for a first customer. So in parallel, we see again here the KDE Free Qt Foundation. I think that's interesting because, as I mentioned, that happens fairly early in the KDE history. But if you look at the Trolltech history, it's fairly early as well. So there's been kind of this symbiosis between Qt and KDE very, very early on. One of the things is that that's actually the founders of Trolltech who actually pushed for the creation of that foundation to protect KDE from themselves or themselves in the future, right? So I think that was a very smart move from their side, and we're actually very grateful they did that. Then we get Q2. During the 2000s, there's a push for embedded, and there's also a push for having more things under the GPL, which was not the case very early on with Qt, which had its own license, which was not GPL. As for the push for embedded and mobile, so there's not yet the smartphone that we know today, but there were PDAs back then. And so Sharp, Japanese company, actually made PDAs which were based on Qtopia, which was a small shell based on Qt for this kind of devices. So the story for embedded and mobile goes way back. Similarly, in 2004, they did the phone edition for Qtopia, and that was more like a proof of concept or a way to display that you could use Qt for these kind of things. 2005, we get the Qt 4, which has been a very complicated version. If you had stuff working with Qt 3, that was not a smooth sail to go from Qt 3 to Qt 4. Lots of new APIs in that particular version. And as we see, there's the Windows version of Qt, which was available under the GPL. A couple of years later, Trolltech gets acquired by Nokia. We see QML and Qt appearing in 2010. And in 2011, the Qt platform abstraction is introduced in 4.8. It was not very much leveraged at back then. There were still many things which were not going through that abstraction. That's actually where when it appears, and then it gains it becomes more powerful over time. Keep that one in mind, because we'll get back to Qt platform abstraction at some point. 2012, the company is acquired by Digia after Nokia, where we've seen basically Nokia stopped making smartphones and went back to making boots. And so it gets under the stewardship of Digia. And 2014, so 10 years ago, there was a demerger between Digia and the company that they bought. So there are still ties between them, but the Qt company becomes more independent from the Digia day-to-day business again. Fast forward to 2020, we get 6.0, and 2024, so 6.7. All right, so our stack, if we want to look at it at a very, very high-level view, we can see it this way, which would be, we have, so everyone sees my pointer, right? If I do this, I guess so. So we have the base workspace, which is basically Queen, Plasma shell, okay? So that would be that top-level box here. Then we go to applications, so that would be things like Krita, Dolphin, Eliza, okay, regular applications. And both of those are built on top of the toolkit. What I call the toolkit for the purpose of that talk is Qt and KDE Frameworks together, okay? You can make applications, I mean, regular applications with just Qt. If you want to do something like the workspace, it will be harder, so you would probably need something like some of the things we have in KDE Frameworks. Or you would have to re-implement these kind of features. Both are the toolkit and the workspace are built on top of the display system, which can be x.org or Wayland. So nowadays, there's clearly a push to go toward Wayland, but it sits on top. The main difference I'm making between a regular application and something which is part of the workspace is that the regular application can just live on the toolkit and don't need to have special access to the display system. While for the workspace, while the toolkit wouldn't be enough and you probably want to go one level deeper, right? And you have that dependency on the display system. All of it then sits on top of the kernel, so which would be a Linux or some variant of BSD, very commonly Linux nowadays. And that kernel is actually running on top of some hardware. There's one particular box here, which is the integration. That's basically plugins for the toolkit to play nicely in the workspace. This is a very important piece of what we do on the workspace side. And that's something that you always have to keep in mind when you're actually working on the workspace. Sometimes that can be a bit of a leaky abstraction from time to time. So sometimes for applications, you actually have to be aware of its existence. But when everything goes well, from the regular application standpoint, you don't need to know about it. We could stop here, right? That would be a way to have like that very high-level view and say, okay, that's how it's layered. Obviously, we won't stop there, right? I'm just kidding with that. But that could be a way to stop and have it in, I don't know, 15, 20 minutes and to have an history part. All right, key takeaways for that first part. The initial KDE vision is still resonating with our products today. As I mentioned, the network transparent, which is still very much of a thing through KIO, for instance. Surprisingly, Corba has been defining to our stack, and that's what led to K-parts and dbus that we have nowadays. One of the fun facts is that if you want something like K-parts, you pretty much need something like KIO to support its features, right? That's why the three of those are kind of working together, in my opinion. The form factor discussion and going on the mobile, that goes back a long way if you count for the Qt history, right? From the dates we've seen, that's actually very early on in its history. So clearly, it's not the most popular option for mobile. We would like it if that was the case, but the state of the industry is what it is. But it's so early in their history that they took care of that it's actually a very mature product to do that. And even on the KDE side, there's not everything on the KDE side, but there's a few frameworks which are already mature for this kind of uses. So we are kind of ready technically, not really on the product side. No, that's wrong when I say not on the product side, but we kind of like the hardware where it would be by default, installed by default, right? One thing I didn't stress, but if you look carefully at the dates I picked, is that Plasma has actually been created before Qt and QML, right? Nowadays, people getting in the community today, they're like, yeah, Plasma, that's built on top of Qt and QML, but that was not always the case. And so there's been a life before that, and I would get back to it a tiny bit at some point. All the products we have a well-defined role in the stack, right? From the boxes I showed, they go either in the toolkit or that's an application or that's part of the workspace. Okay, that's one of the three always. And so one of the goals here, and what we will talk about later on, is how to keep it all properly integrated when we use everything together. All right. So we'll sidetrack a bit on how applications are made, and we'll focus on how a Qt application tends to be structured from an architecture standpoint. The objective here is to have a better idea of how the event loop works, because that will be important later on. To have a slightly closer view to the platform abstraction layer I was mentioning as being important, because again, we will get back to it later on when we really talk about the integration between the different parts. And we will see first few ideas on how we leverage both of those. And we will also have a conversation about how the application code is structured between KWidgets applications and Qt applications, which are really the two graphical stacks which are used within Qt. They have different properties, and people making applications with those, in part for historical reasons, they have a particular way to structure them. So there's some insights to gain for that. So that's generally where I do the signals and slot refresher. I'm not sure if that applies for everyone here from the names I see, because I see very well-known names among yourselves, whom I would expect to know that, and then I can skip. Or there are people I don't know, and I'm not sure if that makes sense for them. All right, in doubt, if there's, yeah, okay, there's one person who stepped forward and admitting doesn't know about it, so I will cover it to not lose anyone. That's a very quick refresher. That won't make you an expert at Qt just with that, but you will get an idea of how the signals and slots, how they're important in the way we make applications. So the model there is that you have an object which emits a signal when something potentially interesting to the outside happens. One or more object can receive the signal, so within the same application, one or more object can receive the signal thanks to a method having a compatible signature. That method with a compatible signature, that's what we call a slot. Okay, so you can have an object which say, "Yeah, something happened to me. Here is the details about it." And if there's another object which is interested in that, then that has to be received on the slot. So it's a model which is nice because it makes it really easy to do event-based programming, which around the time where Qt appears, the only way to do that is generally with C callbacks, where you have void pointers that you have to cast and you can make mistakes and so on. While there we have something which is richer and safer, while still making sure we have loose coupling there. Code-wise, that looks like this. So let's imagine we're doing some kind of seashore simulation. We would have beacons, lighthouses, something like that, and then boats, okay? So I could have like a class, which I call beacon, which inherits from QObject, because to get the signals and slots features, I'm simplifying a bit here, but to get that feature, you would need to inherit from QObject. There's a macro which hides some of the magic behind that. Okay, it's appended to some symbols. And then there's a bit of, so someone mentioned the mock, of extension to the C++ language. That's one way to see it, which is processed by the mock, where you can say, it's not a regular method I'm declaring after that, it's actually a signal. So if I'm making a beacon, I can say it has a signal, which is to say, okay, here is some beam of light, and it's coming from that position and that angle, because we're imagining like we're making like a lighthouse, right? It has a fixed position on our seashore, and then it turns and emits lights in different directions, right? And the angle that we imagine there. On the other, somewhere else in my system, I would have something else inheriting from QObject, which would be a ship. And then this one also has the QObject macro. And then, so I got a mistake there. It should be public protected or private. It can have a public slot, say. That's a public slot. We say light spotted, and light spotted at a position with a given angle. If I have that, then I can, so I didn't, for brevity, I didn't give the code for initializing those, but we can imagine that we have a pointer to some beacon that we call lighthouse. We have a pointer to some ship that we call tanker, and then we can connect the lighthouse beam of light signal to the tanker light spotted slot. Once that connect has been executed, every time the object we point on with lighthouse as its beam of light signal emitted, then light spotted in the tanker will be called, and we can then react to that information. To put it all together, that's basically how it would look. So we would have the lighthouse, right? And in the implementation of beacon, we can imagine having something like a function rotate, to say we rotate the light on top of our lighthouse. And so we change the angle by some amount, and because the angle changed, then we emit beam of light again. On the other side, we can have, so the implementation for light spotted, which would receive our position, and then we can memorize that, you know, oh, okay, there's one lighthouse there, and I will use that to find my way. And the connect is basically what makes sure that the information goes. One important point to see there is that we don't provide an implementation for the signal, okay? That's provided for us by the mock, basically, but we provide the implementation for the slots. All right, so the event loop there. The event loop, that's like one level below in terms of abstraction. So one simplified way to see it, so we'll stay with the event loop a bit longer, we'll see more details about it. But one way to see it is that there is the system, which can be many things. Something happened inside of the system. Typically, the user typed something on the keyboard, or the user moved the mouse, or there's a socket which got some data which arrived, or something like this. So something happens. When something happens, The event loop is notified of this. We'll get back a bit more on how that works. Based on that, it determines which kind of event that was. Was it the keyboard? Was it network? Was it mouse or something like this? Once it determines the event, it dispatches the event to some object. That object can be something in the toolkit, or that can be something from your application, depending on the event and depending on what implementation you provide. And then, because we've been talking about signals and slot, that object would have inside of that implementation, if the event was interesting, changes states internally and says, oh, my state changed internally, I will emit some signal, right? I emit some signal. If that signal is connected to a slot into an application object, I can do something with that, calling into more objects and so on. And then the control goes back to the event loop ultimately. Okay. One of the things you're allowed to do from within your slots and the implementations in your application objects is to say, well, I will create an event which would be synthesized, and then I can post it to the event loop as if I was the system. Okay, so there's a way to go back to the event loop from your application objects and to get something processed at a later time. Okay, signals and slots, I'm simplifying a bit for now, but if you don't do some multi-threading stuff and so on, signals and slots, they are basically synchronous. So that's as if when you emit the signal, that's as if you're calling serially a bunch of methods with an event. That's actually something which will be later when the control goes back to the event loop, and that the event loop actually pick that particular event from the queue. The corollary of that is that ultimately all the application code you're writing in your application is actually triggered by an event loop. Now, on that particular slide, I show the event loop like one single all-knowing thing. It's actually kind of a lie. If we zoom in on it, the event loop, at some point you figure out that the event loop doesn't exist, or at least it doesn't exist as a single entity. So what we have here is still a simplification of the real deal, but that's at least showing that what we call the event loop is actually processed in many different objects. So if you made a Qt application, you generally have a main function. Inside of that main function, you create an application object. And the last thing you do in your main function is calling the exec method on the application object. When you do that, that's actually when you kickstart the event loop. So you're calling exec from your main on the application object. If you look at the implementation inside of KCore application, KGUI application, and so on, it pretty much does only one. It's not true, it does more things, but for the sake of the event loop, it creates an event loop instance and it calls exec on it. That event loop instance basically just calls it. It's a loop, right? So it's kind of an infinite loop and just calls process events on itself. And inside of process events, it doesn't do anything. It actually calls process events on what is the event dispatcher. That event dispatcher will then pull events from different sources. And those sources can be posted events. So posted events, that's, you remember on the previous slide when we were going back from one application object and we were saying, okay, I go back all the way to the event loop, I posted something to the event loop. That's that source, okay? If you post something yourself from your application code, it's coming from this source. That can be coming from a timer which fired off, okay? And timers, they can be implemented in the system or they can be implemented straight in Qt. That can be from a socket notifier. And so that can be, again, something coming from the system or implementation in Qt itself. And socket notifiers, despite the name, they are not only about network, okay? That's also how we deal with mouse or keyboard events, mostly. And then there's the display system source, okay? So it pulls the sources and can find an event somewhere. Then grabs it, and then dispatches it. So to dispatch it, it then passes it back to the application object, which has the rules for dispatch. And based on those rules, it will decide, okay, I located which object should process that event, okay? And so there will be a receiver object which is determined. Now there's one trick, which is that the application object doesn't pass it to the receiver object right away. That receiver object might have registered what we call event filters, which are basically objects which re-implement the event filter method in them. And then they will see the events before the receiver object. So inside of event filters, you can do things like trigger some piece of behavior and then let the event go further, and then it will get to the next filter. And if you're the last filter, then it gets to the receiver object. Or you can also catch an event and make it disappear so the receiver object will never see it. Okay, that's basically the kind of filtering you can do. If none of the filters did that, that is like grab it and not let it go, then it will end up in the receiver object. And so the application object will pass it to the event method inside of the receiver object. One thing to notice here that the situation may vary for user events depending on the system setup. Because some things might come from the display system, some things might come from socket notifiers. That depends, for instance, if your application is sitting on top of X11, the keyboard events will probably come from the display system source. Now, if you're on Wayland, they might come from something else, right? And then in that case, you would use socket notifiers. So that can be wired differently depending on the system. And that's basically done at runtime. One thing to keep in mind is that the application, which I cannot show here, is that the application objects has hooks. So there are startup shutdown hooks, and that's a way for you in your application to, for instance, in your application, to declare hooks, which will be executed at important times during the application object life cycle. So just when it got inside of exec, for instance, or when the event loop will be kickstarted for the first time, you can have one of those hooks being called. You can also have hooks being called when the application is about to exit, right? So there's ways to react to important things like that. I mentioned it here because I didn't know where to fit it. Keep it in mind because that will be important later. All right, but that seems all simple and so on, right? But there's actually details I'm kind of leaving out by describing things this way. Where do the event dispatcher is actually coming from, right? Why the sources are wired this way, and what about the display system, right? Where is it coming from? Which display system should I talk to? For sure, not all of that is wired at compile time. Because you could compile your application or you can compile Qt for a system where X11 is here and so on, and then you run it on another one where Wayland is there, right? So you need some way for things to actually adapt. That's when we get to the Q platform abstraction, okay? You cannot have everything which is wired at compile time. So they have like a plugin system and there's APIs for that. And so you have that layer which creates that flexibility. The intent is to make that layer, though, invisible to the application developers. If you're making just regular applications, the Q platform abstraction, you shouldn't depend on it. You shouldn't have to mess with it. You don't even need to know it actually exists. If you're making, if you're trying to adapt Qt for a particular workspace or a particular system, because you're making something embedded, or like the KDE community, you're making a workspace, then you need to know that it actually exists and you will need to integrate with it. That's a plugin system. That's interesting because that's a plugin system with two levels of abstraction. So we see that there are two levels of plugins in there. And most of the plugins are actually provided with Qt. So the Android integration plugin is provided with Qt, the Windows integration plugin with Qt. For Wayland, that's with Qt. For X11, so XCB, that's with Qt, and so on. So there's a few more. So the first level of abstraction, you don't really need to do much. Now, if we zoom in a bit, we get the platform integration plugin. This one will create the platform integration, one of those which I was listing on the slide just before. We were asking the question where the event dispatcher is coming from. Well, that's actually that first plugin which will create the abstract and an instance of something inheriting from KAbstract event dispatcher. And that's during that creation time that things are actually wired based on the actual platform you're running on. So that problem is dealt for us, kind of. Now, that platform integration actually creates other things. So you have a window for your, let's say you're making an application with several windows. Every time you create a Q window, which is the application API side of things, there will be a Q platform window to back it up, right? So I'm creating a Q window. I need to have resources inside of the system representing that window, and I need to create them. So on the QPA side, there will be a Q platform window being created to match it. Okay, so that gets to the platform-specific resources this way. There's more platform things, obviously. The one I'm interested in here is the Q platform theme, because this one will create more things along the way, and this one will actually go through a plugin system again, okay? So we got a plugin here, create things directly, but for this guy, it's actually created through a plugin system again, potentially, okay? So that's where we get our second level of plugin system, and that's where it would become interesting for a workspace like Plasma. And the platform theme will be responsible for creating more resources, platform-specific resources, like the Q platform dialog helper. That one is the one responsible, for instance, of creating the file dialog or the print dialog and so on. So we see that it's not something which should be tied to a physical platform, which would be like on the platform integration, but more something which is, well, am I running on GNOME or Plasma or something else, right? So that's why it's attached to the platform theme. You get also for the system tray icons, the icon engine, which is created there, or the menu bar is created there, right? That's also one of the mechanisms which allow to have the menu bar outside of the window, for instance. But wait, so we mentioned that most plugins are provided with Qt. The KDE file dialog isn't implemented inside Qt. So it's not, it's implemented using Qt, right? So we ship a plugin somewhere. Yes, we do. And so that's a platform theme plugin. I will get back to this later on. But for now, make a mental note of this integration point, right? At the very, remember when we had that integration box earlier on with the stack, that's a very strategic part of that box is the Q platform theme plugin. So as I mentioned earlier, but I find that actually funny, Plasma and KDE Frameworks have that, which is a bit special, that they have code both on top and below Qt, right? If you're another platform, like GNOME, for instance, right, they don't have this constraint, because none of the things they implement are based on Qt, right? But we implement things with Qt traditionally, and then we need to integrate inside it. So we have that kind of little challenge. So I won't dive into it for that particular training. That would be an interesting topic as well. But think for a minute about KWin, which is implemented using Qt and QPA, because KWin, right, uses Qt. Qt tries to connect to Wayland compositor, and KWin is also the Wayland compositor, right? So that creates interesting problems. All right, now let's focus more on the applications, as I mentioned. So we've seen a few integration points already, which I will get back into, but I promise for that section to also talk about the architecture of applications. So that's what we are doing here. For applications, if your application is the typical KUtWidget application, so I'm ignoring KUtQuick for now, it's really about I'm making an application and I made the choice to make that application using the widget stack graphical stack inside of Qt. Then traditionally we do it this way. So it's not only about having one of each, okay? We generally have many models, many widgets, many views, what I call views here, okay? So it's not about having a single class of each type. It's more that when you make an application like this, you have that particular pattern that we see on the left-hand side of the slide, repeating n times for the different features of your application. So you have to imagine several models, widgets, and view. And you have to imagine having complex relationship between models, like having a model which is used by more than one widget and so on. One thing, though, is that generally you have each widget which has only one view. There are some exceptions to that, but the most common case is one widget, one view, but one model, many widgets potentially. All right. So the models that your regular C++ business objects say, and you potentially they inherit from KObject. That's probably something we might want to do because that would be a good way for us to interact with the widgets providing signals, right? So we would provide the signals and then we would have some methods. The widget is generally written in C++ as well. It inherits from KWidget, okay? And it will provide very often some signals and some slots. The slots will be used to react to something happening in the models. And the signals will be probably to notify the view that something happens. Now the view, that's C++ as well, but you generally don't write that C++. You generally use Designer, either as a separate application or something integrated into Creator nowadays. That will create an XML file, which is a .ui. And then we got the UIC tool, which basically processes that and generates some C++ code, which will be your view. So you don't get to write that one, but you write the other two, okay? Now, one way to see it would be to say that that particular architecture is basically the model view control thing. Because if I relabel a widget into control, that's pretty much what we have, right? We have a model, okay? We have a view, and then the control is responsible for creating the view and making sure that the view interacts properly with the model. In widgets application, what might happen is that the control part might create models, but sometimes it just reuse models, objects which have been created some other way. So it's fairly close from that traditional pattern. There's just one catch in the way we are doing that for KUtWidgets applications, that very often we inherit from KUwidget for the control part. Now, from the software architecture standpoint, you generally want your control part to not be dependent on your graphics stack, which is what happens here because we inherit from KUwidget. So that's a bit of an historical artifact. That's a bit because we're lazy as well, and that makes less work to actually get things started. But yeah, so we tend to have that particular dependency. I will get back to why I'm making that point later on. In terms of code that would look like this, we would inherit from KUwidget for the widget part or control part. We have the KObject macro, we provide a constructor, and we create an instance of the view inside of that control part. When we create the UI, we also have to call a setup UI on it. On this, we might have a bunch of connects to and from the widgets toward the UI. And you will probably have the slots that you're connecting here, which manipulates the model, which would point to, I forgot the star here, but imagine that's a pointer, where we would point to internally. That model can come from the outside, and we probably would have a setter get the model. That's not always the case, right? But that might happen this way. If you got a set model, you probably, again, have a bunch of connects, need to change between the models to connect to some of the signals from the model to your slot so that you can react to that, impact the UI. Putting it all together, you would create an instance of the model, an instance of the control. By creating that one, you also create an instance of the view, and then you set the model part on the control and show the control. Okay. Now, if you have a Qt application, the pattern is slightly different. So again, not a single class of each type, pattern which is repeated over and over several times. And you have to imagine that the wiring is complicated between all the instance of models and what I call proxy or service here. And also between the view and the control in that case. So that starts similarly. We have the model objects, okay, C++, several of them, they have signals, they have methods, right? Then you would have like a control part, which I will call here proxy or service. That one will react to signals coming from the model, would have methods, which it calls on the model, okay? And this one then is exposed to QML. And what is exposed is methods from it and property bindings. In the view, then, we would write it in QML using Qt, and that view would react to change through the property bindings and might call things on the control part. In that particular case, the view creates or the view uses, okay, the service. That depends how this part has been exposed on the QML side. And if you want to have only one, for instance, being seen from the QML, or if you want to allow creation of them from the QML. So that's pretty much between that and or here, that's pretty much a design decision. Code-wise, it would look like this. You inherit from KUbject for your proxy, KUbject macro. Then you declare your properties. You say that's a QML element so that it's actually exposed on the QML side. You have a constructor. You have getters and setters for the properties above, right? So if I have a model ID here, I would probably have a set model ID. And I would probably have a getter called model ID. And if that changes, I would probably have a signal. So we have the read, write, and notify parts on our properties, and we need the implementations of those in here. And then in the private part, we would have something model to get a pointer to the model, which might create it, which might locate it based on some other property like that model ID property. That's maybe something we use to locate the right model object inside of some cloud of object or something like that. On the QML side, to write the view, you would import Qt. We assume that the proxy has been registered in the or.kde.app namespace. That's actually decided at the build time. So we import that namespace as well. And then we can create a Qt item. We can create an instance of our proxy, give it an ID, say, yeah, find the model this way with some string here. Was lacking imagination, I guess. You set up the model ID, and now when we call things here, or the property we see here are interacting with that particular model. And then we can have like some text and say where the text of the text element will be whatever we add in the value property of that proxy element. To put it all together, then in the main, we would have a QML application engine, and then we would load from the module or KDE app the view. And we are assuming here that the view.qml contains the view. that we were seeing on the previous slide, and that it's been registered in that or KDE.app module as well. So in a way, I called that section the anatomy or architecture of a Qt application. In reality, we have like anatomies, right? We've seen two different patterns, right? So the pattern used for KWidgets is kind of the MVC pattern, model view control, as I mentioned, but with a twist. That twist being the fact that we're inheriting from KWidget. That kind of gets in the way of reusability. That's a lesson that we learned when moving from KDE Libs to KDE Frameworks and now trying to have more QML-based things. And that's because we kind of overfitted to the composition pattern of widgets, right? We want to compose them like widgets, and so we made our control part widgets. And so we are kind of stuck with widgets, but that control part could be independent from widgets and be more reusable this way. It doesn't have to be like this. Now, the pattern we have on the Qt side is, in my humble opinion, superior. I mean, I don't care about is Qt or KWidgets better. I'm just saying that naturally, for one, we went toward an architecture pattern which is superior. There's less coupling between the view and the control, or at least if there's some coupling, it goes in the right direction. In fact, in the literature, you could argue that it's closer to the model view presenter pattern rather than the model view control pattern. It's, of course, not impossible to have Qt-like approach, but for widgets-based applications. It's not often done for historical reason because of the way the documentation on Qt is worded and so on, right? There's been on the Qt side, so for the 6th cycle somewhere, I don't remember exactly in which version, but the Qt bindable properties which were introduced, and they were supposed to make that easier on the C++ side, to have an architecture which is similar to what I've shown for Qt, but on the C++ side, and so with widgets. But nothing in KWidgets uses them, which is kind of a bummer. And so we've seen a limited adoption of them on KDE Frameworks so far. Again, I mean, there's quite some legacy and history there. So it's not like we could turn around and then change all the APIs to leverage this. So why did I cover this? Why it's linked to the history section. We did a lot before Qt was around. So a lot of our stack comes from application following the KWidgets typical patterns, which means that lots of things in no frameworks, you cannot easily reuse them outside of KWidgets context. And that makes it harder to reuse those, even though they have value, in Qt applications. So that's more an advice for the people who want to contribute application that I'm trying to push here. Pay attention to what you pick and where it's coming from. And if possible, I mean, the temptation is great to actually rewrite things, but there's years of knowledge and bug fixes and pain, right? Even though they are dependent on KWidgets in the existing business logic we have there. So if possible, it's actually better to locate something which might be dependent from KWidget, but to retrofit it into newer APIs instead of duplicating the features, okay? So that's something I've been thinking about, and I will actually have a talk about focusing just on that topic at the Qt World Summit in May. So there will be more content about that later on. All right, the anatomy of KDE application now. Well, the anatomy of KDE application, that's pretty much the anatomy of Qt application. Again, it used to be different, but now it's pretty much the same. It's just that generally we have kind of more dependencies. That is, if we want to draw a line, I would say that nowadays a Qt application, that's an application which uses only Qt. KDE application, that will be an application which uses Qt and KDE frameworks. That's basically it. All right, questions and answers again, and we'll be a bit more than an hour in, so I would give you like 5 minutes break after that, so that you can refresh your brain a bit, because that's packed already with information. So which are the sources of events for the event loop? Yeah, so we've seen miles, Windows system, sockets, timers. Yep. And I think between those two answers were pretty much, yeah, true. I almost forgot those. Yeah, so other events, that the posted events. Yeah. All right. Which object is responsible for dispatching events? No, that was the trick. It's not, so the event dispatcher is very, very badly named in my opinion, because if you remember what I showed, it actually doesn't dispatch the events. That's actually the application objects doing the work of dispatching the events, okay? The event dispatcher really is more about the polling of the sources, but then it just, whatever it gets, it just passes it along to the application object, and that's the one doing the actual dispatching. What happened to events when they get dispatched? Yeah, first filtered and then processed by the object. Maybe. That's the important part which might be missing there. Maybe, okay? There's a way in the filters to actually say, I swallow it, and then you won't get to it. See it, yeah, or dropped in the filter. What is the relationship between events and application code? So your source code runs because of an event. Okay, there's an event which has been received somewhere that triggered something which trickled down to some of your objects. Okay, that's more what I was fishing for there. Now, what Bernardo proposed, which was application listens for events and may emit them as well, is not completely wrong. I mean, I wouldn't use the word emit. I would, just to be more precise, I would use the word post or send rather than emit, just to avoid the confusion with signals. So that's true in that way. The listens, kind of, I mean, there's the event handler, but that's very, very indirect, right? It's not like you can get the event directly. It's because it went through the dispatcher and so on, and then you get it. Right. Which Qt mechanism is putting the event loop and its sources in place? That's the QPA, yeah. That's the QPA, because if you remember in the QPA, there's it creates the abstract event dispatcher, which is the one which will actually pull the sources and so on. What is the usual pattern for KWidgets applications? Yeah, MVC, model view control. You remember I said with a twist. And with a twist, that means that this pattern gets in the way of something. What is it? So not MVC per se, right? But the MVC with a twist, which I mentioned, it gets in the way of something. Yes, reuse, because controllers are too tightly coupled to views. And which pattern, the Qt quick pattern seen here, is close from? It's close to. Should have I? It's close to, I guess. Yeah, model view presenter. That would be the one. All right, key takeaways. All right, so Sandro saying, for Qt quick apps, isn't a more prevalent pattern multi-value views talking directly to models by calling data and friends rather than going through proxy? Yeah, in a way, I'm giving a more detailed view. But yeah, that could be, you could completely imagine having something in your domain being a key object and you expose that directly. I would argue that if you expose it directly, you might miss something. I'm not saying it doesn't exist, right? I'm just saying that if you get toward that pattern, you already have the model, which is the base, how things are modeled and so on, without really checking that that the changes make sense from business logic perspective, right? So you need something carrying that business logic, and that higher level rules that you might want to have, you cannot fit them in the model properly sometimes. So then you would have to have something in between, right? If you get that, then that's the one that you want to expose to Qt Quick, right? You don't want the view to straight go to the data. That's basically what I'm trying to stress here. All right, apparently that answers, so good. All right, so key takeaways here. The event loop that's in fact quite a few objects in interaction. Okay, there's don't find like a single object which would be the event loop, even though we find something which is named Q event loop, that's actually more objects in interaction. We have quite a few sources of events that we don't necessarily expect. The application object is very central to the event dispatch mechanism. The application object provides us hooks, which I kept mysterious for now, but they are important. QPA has a strong say in how the event loop is wired. Okay, so QPA is really an impact on that. QPA is also an important mechanism for us to plug our own platform behavior, and all QPA use is fairly unique since it is Qt-based all the way. Regarding the applications, so to maximize reusability of business logic and to structure your application similarly to a Qt Quick application, even if it uses KWidgets. And there's really not anything specific anymore to applications coming from KDE apart from their dependencies. All right. With that, we're getting in the KDE Frameworks section, which I will probably have to run through a bit. It would be fairly quick-paced and so on. So I would propose you a 5-minute break. So we're 20 past right now. So let's get back to it at 25 past. All right. See you in a couple of minutes. I will get back a drink and get back there probably before the time. So if you have questions, you can type them during the 5 minutes break, and then I can answer them. See you in a few minutes. Let's continue. So that new section or chapter will focus on KDE Frameworks. So what we will see here is, so we'll have a whirlwind tour of KDE Frameworks. We won't see them all. Okay, there are plenty of those. We won't see all the APIs there because there are tons of APIs there. What I want to give you here is a feel of the amount of features available, which is great, and to understand better how it's structured overall. Because if you're making an application that can help you decide between, okay, I will pick that frameworks or not, right? Because then you will know what you pay if you pick it or if you choose not to use it. During that time, and since I said I won't cover all the frameworks, but some of those I kept were because I knew I would be able to highlight some of the integration points we hid in there. So we will see some of those, and we will see, for not all of them, but for some of them, how they relate to Plasma, okay? Because we're talking about frameworks, Plasma is supposed to sit on top, but you remember what we said, that this integration trick. I said the toolkit is both Qt and frameworks, so obviously it will relate to Plasma in some way. All right, let's get started with that. Why did we go to KDE Frameworks? Well, KDE Libs was one repository, lots of libraries dropped in there, and that was an untangled mess for historical reason, right? It kind of grew more than it was designed back then. Some things, I mean, I'm a bit harsh when I say that. It was, I give the picture that it was a mess. It was not, right? Really a mess, but obviously there were more things glued together than really needed sometimes. So with frameworks, we try to have a direction where things would get better. So if you got interested into frameworks and you looked at it, you might have seen that particular diagram, which I made back in 2011. And it's basically showing a matrix, okay? We have 2 dimensions in there. So that's basically the green, orange, blue. And for one dimension, and then the saturation of color for the other dimension. The dimension that everyone talks about, that the tiers, okay? So we have 3 tiers in there with their own dependency rules, okay? So if I have something which is on that line, so at the bottom, which is tier 1, we basically say it's tier 1, it can depend only on Qt and system libraries. Okay. Now if that's tier 2, we're saying it can depend only on tier 1, okay, and Qt and system libraries. If it's on tier 3, then we're basically saying, well, at that point, we give up, that's free for all, okay? It can depend on tier 2, it can depend on tier 1, Qt, system libraries, or other tier 3, okay? We could have went for fully hierarchical, right, and say, okay, we're having tier until we have dependencies. Then at some point, we would have something so high, we would say, well, that's tier 37 or something. So it was not very valuable for people to pick. What we wanted was to give an idea to people of how painful that would be to depend on something. So 3 levels are plenty enough. So you basically know that, well, you already picked Qt, otherwise you're not there, right? You're picking something tier 1, that's kind of an easy dependency to pull, right? If you were already depending on Qt and system libraries, that's just one more library you're adding to the mix, basically. If that's tier 2, you know that you're not pulling just one thing. You're pulling something and some more, and those won't be too painful to pull, right? But everything all together, that starts to be a bit bigger price to pay. If that's tier 3, then you know that you're in for really being committed to that dependency, okay? That's kind of what we're trying to convey here. Now, there's a tier 4. This one can depend on pretty much anything. This one is a bit special. It's a bit outside of the rest of the model in the sense that it basically has almost no API. It's more that it has a purpose, okay? So that's why it's named look and feel and consistency. This one, so we'll get to it at some point in that talk, but this one provides basically no API, but it's the one which provides everything we need to exercise the integration points that we'll see to make sure that the integration between everything happens. So the tiers is the thing that everyone talks about because that was the easy one to sell, I guess, or to understand when we presented that. But there's another one which everyone for some reason ignores. So if you've seen my talk 2 years back, I've been dabbling into, okay, maybe people are not talking about it because that was not clear or too complicated, and maybe you should have went for something easier as a model. But here it is. We also have types. The idea of types are, again, in a way, so that's why they're a bit weird and maybe harder to understand. They are mixing up 2 things in a way. Dependencies again, but where the tiers are about build time dependencies in a way, right? And what you link to. The types are more about runtime dependencies. Is the dependency I'm pulling and linking against because of its API, will it also bear some runtime extras that I need to provide in a way for things to work or not, right? That's a bit what we're trying to provide to convey this, plus the idea of is that something which makes it easier for me to integrate with the system, or is that something where there's added value with the runtime dependencies? So that's why we have the 3 types. So functionals, they're basically Qt add-ons, right? They have no runtime dependencies. They are basically just pure logic in a way, provided by a library that you can reuse. Integration frameworks, they have optional runtime dependencies. The thing is, they're aiming at integrating with a given platform. If you think about notifications, you could perfectly implement notifications completely within the application. But if you want to integrate deeper with the system, you might want to talk to something. And so that's a runtime dependency that you need in that case, okay? So that would be more of an integration framework. Solutions, they have mandatory runtime dependencies, but that's part of the design. There's a runtime dependency because that was a conscious decision on the software architecture side of that framework. Because we want to have some resource sharing, because we want to have some resilience, or because we want some scalability or something, okay? And because of that, we need to have the runtime dependencies. Be it tiers or types, they are both part of the information listed in the meta info YAML files of the framework, okay? At the root of every framework repository, there's that file. Inside of that file, you find tiers, column, or types, column, and then it will say one, for instance, and functional, okay? You will find that everywhere. If that's missing, that's a bug. You can report the bug. One thing as well to keep in mind is that when we published it the first time, that's something I think which got lost in history somehow, we mentioned that as a maturity framework, okay? As a maturity model. What we wanted was to say, because right now you can say, okay, I'll take today, and then each framework can go in one of those boxes, those 10 boxes, okay? Let's ignore that one. So everything which is tier 4, for all the other ones, okay, I can pick any one, and then it will fit into one of those 9. Back then, and that's why we're talking about a maturity model, what we were saying is that we shouldn't stop at, here is the situation of today. We should think in terms of, we see where it is today, and if we pick one of those, we should strive to push them down and right, okay? So ideally what we would want, I'm not saying it's possible with everything, we will never get there, okay? But at every step of the way when we are making them evolve, one of the intentions where if I'm looking at something which is integration tier 2, for instance, I'm touching it because I'm doing some maintenance or something. Do I have an opportunity to get it closer to actually move to integration tier 1? Right? And in that case, I should do so. Okay, that's what we were looking at, right? That in some way we would push everything down and potentially to the right. Maybe there's something where I made a software architecture choice which pushed to make it a solution, but now when I'm looking at it again today, maybe it turns out that I could have the same properties but with a different internal architecture, and then maybe it would be more functional nowadays. So that's why we're thinking about pushing things like that. All right, now a disclaimer. This section is a bit more of a catalog because we're going through the frameworks, and catalog, I don't know about you, but yeah, quickly that can become boring. This is not exhaustive, okay? We won't cover all the APIs. We would have to cover more than 70 frameworks otherwise. Expect some of the classes to be barely described, okay? And actually to stay within the 3 hours, I would probably have to skip even some of those slides in there. So we try to focus on what's very important. So now it's time to brace yourselves. All right, let's start with the tier 1. All the following frameworks build straight on top of Qt. The obvious one is KCoreAddons, provides plenty of different services, okay? People don't even know about them most of the time. There's a shared data cache, which allows you to share data between processes, ways to handle autosave files, an extension somewhat to QProcess, with more options, the way to describe the about of an application, fuzzy matching, user handling, the necessary to make plugin-based architectures, a way to expand macro strings, and so on and so on. There's one part in KCoreAddons which is very important to me, that's jobs. So in the form of KJob, which is provided in KCoreAddons, which allows for describing a task within your application, which would be executed asynchronously. KJob is an interface for modeling those tasks. it is in no way providing any mechanism for making sure that what you implement is actually asynchronous. That's up to the implementer to do that, okay? And so you can make it wrong and then inherit from KJob and make something which is not asynchronous at all, and then there's no benefit in using KJob anyway. But the real value is in the consistent interface we have for all the job-like stuff across KDE applications, thanks to that common interface. And we'll see that it provides interesting properties due to that. So if you have to make your own job, and we imagine we create a resource, I don't know, on some web server or so on, so we do a post or something like that, we would inherit from KJob, okay? We would set the URL where we want to create the resource, say, and then we would have to override the start method, which is pure virtual inside of KJob, and that's where we plug our implementation, okay? So here we have both to plug the actual implementation of the action we want to make, but also in which way we do the asynchronicity. In that particular case, the example I show here, you use a trick through meta-object with the invoke method trick, where we use a queued connection so that we create a posted event, which will be executed later, representing a call to the doStart method that we have internally, okay? But that's one way of doing it, but we could do it with, I don't know, a thread or, yeah, something else, okay? That doesn't quite matter. Internally, we will have, so the doStart, which does the actual job, and then here we have an unfinished, which we will call at the end when we consider, okay, I'm done. I'm actually done with my request. So inside of doStart, we will do something asynchronous. For instance, we could use a queue network access manager or something like this. So we would connect to some signal somewhere, for instance, because we made a HTTP call, okay, we have something representing the request, we want the reply to be available, so we need to be notified when the request is done. So we have something where we react to it, okay, and then we plug that to the unfinished slot internally, and the unfinished, we check, was it a success? Yes, no. If that's not a success, then we position an error code, an error text, and then we emit result. What's important here, that set error text, emit result, that's actually inherited from KJob, okay? So all 4 jobs, in the end, they call into those particular methods. And that's one way we use to ensure that they all have kind of the same behavior as seen from the outside to respect the interface of KJob. Once I have that, I can create a job. It's a regular key object, I can give it a parent. Pardon me. I can set the URL. Then I can plug on the result signal of my job. Again, that's something inherited from KJob, okay? So all the jobs have that signal, and then I can plug some lambda to it, and it will be called when the job is done. That one will be emitted from within the emit result that we have here, okay? Which does some extra checking, ending the error, and so on. So I created my job. I'm ready to react to it, but I might want to display the progress of my job, or I might need to interact with the user when something happens inside of the job, for instance. So for that, on jobs, we have 2 mechanisms, which are UI delegates. And UI delegates are here to interact with the user during the job lifetime. Do I need to ask a question to the user, or there's been an error, I want to display it to the user? The job is not dependent on some GUI, so it will turn to, do I have a UI delegate? Yes, then I will call into it to try to interact with the user. But if there's no UI delegate, then it will just leave its life with no real way to notify the user in a way. Another thing is to know about the progress of it. And in that case, we have a concept that we call job trackers. There's no particular interface for those, but the basic idea is that we have an object somewhere, which is a tracker, we'll register a job to it, and now it will display something whenever the job state changes. So typically, if you look at Kmail and you're checking your mail, you see in the status bar, there's some progress which is displayed. that's actually something which is a job tracker. You have a long copy inside of Dolphin, and you see the progress in the taskbar. Well, there's actually a job tracker which talks to the taskbar to actually display that. So that's the kind of stuff we have. And then once my job is ready and wired to everything I need, I start the job. So everything you need to use a job is basically on that slide, be it a job you wrote or a job coming from somewhere else. Okay, those 5 lines here, you basically find them. Note that we also have a class which is named KCompositeJob, which allows to build jobs managing other jobs, job queues, things like that. That can come very, very handy when you start to have more complex logic. On the tier 1, we have KWidgetsAddons. KWidgetsAddons provide many things like our message dialog, which support notifications and the don't show again feature. When you get a message, you can have that don't show again. If you check it, then you will never see that type of message dialog again. We have rating widgets, so for having row stars or the pixmap, column resizers, dual actions, yada yada. I'm not getting into the details for those. Yeah, password widgets, color combo box, date combo box, date picker, page views, page dialogues. Okay, if you need to have like a dialogue with a strip of icons on the side and you see a different page depending on what the user picked there, you can use KPackage dialog. And your different pages, you can choose to have them like with strip of icon on the left or tabs or a tree. And then you can use that to switch. On the tier 1, there's a very important one to me, which is KConfig as well. So KConfig, that's how we deal with the settings in all our applications. So you can get the settings of your application, giving the name of the file storing the settings. You open the configuration, you get a shared config object, so you can do that at several places inside of your application, and you get the same shared config object. You can create config groups. Okay, so you can have groups on those config files, and then you can read and write entries inside of a group. So you can read an entry like alert color, and you say, well, if it doesn't exist in the group, I get that color by default, and then you get an actual queue color directly. You don't have to cast or anything. Or you can write entries, so you can set a font and so on. So one thing which is nice is that here I show open config, but you also have open state config. So if you're well-behaved application developer, everything which is actual config, you would use open config for. If you have things like the actual state of the application, like the size of the window or things like that, which are not really settings that the user manipulates, but some state parts that you want to memorize from one start to another, you would use open state config. We support groups, nested groups. There's also mechanisms which are convenient for sysadmins, like supporting config cascading. So you can have several directories where the config will be looked for, okay? And then it will look in the parent if necessary, which is a good way to provide defaults, which are not the application defaults, but you want to override. Then you want to allow users to change those again. That's actually possible with the cascading. You can go one step further, which is to lock settings. So there's a syntax for that. So when you override the default, you can say, well, I override that default and I make that particular key read-only. So then the user won't be able to change it anymore. Next to that, there's a K-authorized namespace, which allow you to describe actions which are lockable by the sysadmins. And that's actually a nice feature to have. KConfig, within it, you also have something which we call KConfig XT for extended, which is nice because then you provide basically an XML file which describes all the settings of your application. It supports most data types from Qt. So for instance, this file describes the configuration we're seeing in code just before. So we're saying my application will store its settings in settings RC. It will have a group named appearance, and there will be 2 entries in there. One which is alert color, which is a type color, which has this default. Another one which has basically no default, which is called alert font, and which is a font. Okay, and so from that code, we have a tool which is KConfig compiler, which will generate C++ code which model that configuration for your application. So then you can say we generated, so you can control the name of the class. Let's say we decided it would be called settings. Then you can get an instance of settings. You can get the alert color from settings, and you get straight the color. Right? You don't have to remember about passing the default and passing the same default everywhere inside of your application, which would be the easy mistake if you use KConfig directly. It deals with it for you. We provide CMake macros to help with using KConfig compiler. You get type-safe configuration. You can also opt in to have notification changes for keys inside of your settings. You also get all the necessary hooks for introspecting the settings, like is the setting value for that particular key at the default value for now, or is that something the user overread? You can actually know that. There's also ways to deal with the state management to reset things to default, etc. Under the hood, it's all KConfig, okay? So we benefit from all the features, cascading, and so on. No, as far as I know, there's no coupling between KConfig XT and KI18N. Another tier 1, which is popular these days, is Kirigami, which is basically a high-level view of your applications for Qt Quick, with high-level concept like having a drawer for the context or a global one for all the actions of my application, having a page stack and so on, and then you can have components in it. The goal for Kirigami and the API it's exposed is to make it easier to make adaptable, or what we call convergent applications, to make them both work nicely on mobile and desktop, or intermediate on tablets. And they try to follow the human interface guidelines, even though they are getting updated right now. There's quite a few components being provided, like windows, actions, drawers, the page system with routing integrated, scrollable pages, card lists, card grid views, and so on. We have a few more tier 1 frameworks, like KArchive, everything you need to deal with archives, KCoreAddons for iCal data, KDBus-addons with extra helpers for inter-process communications or IPC logs, I18N, item models for useful proxy models that you might want to use, Windows system to integrate with the Windows system, as the name implies, Solid to integrate with the hardware notifications, and so on. Threadweaver, which is a very interesting one, not used enough in my opinion, and it provides a complex multi-threaded job queue, and you can make complex flow graphs for your threads thanks to that. It's really neat. Now for tier 2, so those ones, they depend on Qt and tier 1. We get JobWidgets. So you remember we had KCoreAddons with the jobs, so it depends on KCoreAddons. And it's JobWidgets, so it will use some of the widget add-ons. Unsurprisingly, it will provide implementations for the UI delegates and trackers I was mentioning earlier. So for instance, we have a KDirect job UI delegate, which allows the job to interact with the user using dialogues. There's also a notification job UI delegate, which is the same thing, but instead of having like dialogues, which can be disruptive to the user workflow, we have like notifications which will appear in your notification area and so on. We also have the widget job tracker, which allows to display job progressions inside of the widget. The status bar job tracker, the one I was talking about for Kmail earlier, or the UI server, there's 2 versions of it. So you use the V2 one nowadays, job tracker, which allows to display job progression through the dbus service exposed by Plasma. Okay, and then you get something nicely inside the taskbar, for instance, and things like that. On tier 2, we also have KNotification, which allows to create a notification to be displayed, and that corresponds to an event. And KNotify config allows to expose the configuration for a given event. The way to use it is basically you describe your notification, okay? So you give it a name, some text, some pixmap. If you have actions, like for instance, an open chat, you chat with some contacts, you can do that. And then you get notified if the user clicked on it, and then you send the event. One I like, and this one depends on K18N, is KUnitConversion. It has a very simple API, supports plenty of different units. It's really neat. It even deals with currencies, which I was wondering, how does it do that? Well, unsurprisingly, it has, so it uses a file cache for that, but it has a daily updates of the conversion rates. And if the cache, if you got the network and the cache is outdated, it will query on the internet to get the latest conversion rates. We got also KPackage, which allows to install and load packages for non-binary contents. So if you want to have scripted extensions or graphic assets for your applications, that's an option to go through that. I'm skipping the details for now, but you can look at the slides later. And tier 3, remember, YabiDragons, that's where the dependencies get harder to manage. So we have KCMUtils, which provide KCMutils, so the base class for the configuration modules that we also use for system settings. But the most complex applications like, again, Kmail, Contact, these kind of things, they use KCMutils generally internally. And then we have the KCMUtil dialog, which allows to provide settings dialog displaying a set of KCMutils. So you can neatly separate between the different modules to manage parts of your applications, and then you put them all together visually to the user with KCMUtil dialog. We also get a KPlugin widget in there, which allows to say, okay, I have a list of plugins, list them all, and the user can decide which ones will be loaded or not, or you can configure a single plugin. And KCModule data, which is a more recent implementation, which was actually done by my company for some project, for extending KC modules to know the state of a module without loading the whole GUI. That's actually a system we introduced to be able to have the feature in system settings to highlight all the modules which are not at the default values. We go through the KC module data, but if we had to load like the whole GUI and so on to get to the information, that would be too expensive. So that's a good way to have the information cheaply. It also contains all the necessary to make QML-based KC modules. Okay, so for that there's a KQuickConfig module and KQuickManageConfig module. That's a mouthful, which allow to implement the backend part of a QML-based KCM. In the namespace org.kde.kcmutils on the QML side, you have all the convenient elements to implement the front-end part, most notably simple KCM for the root element or grid view KCM for the root element for config modules where it's mostly exposing a grid of items. We also have KConfigWidgets, which add extra features on everything we've seen. That's where we get the hamburger menu or the command bar, which are really fashionable these days. We also have KXmlGui, which is kind of, I mean, one way to see it is the ancestor of Kirigami for the widget-based applications, okay? That encodes a lot of rules of what we consider a KDE application on the desktop. And for instance, I was talking about the about data earlier, where you get the about application dialog coming from there, the action collection to declare all the actions in your application, and the XmlGui window, factories, and GUI client, which allow you to put it all together, either in a main window or inside of a shell, which would be within something bigger. And if you use those, then for free, you get all the settings dialog to be able to change the default shortcuts for the actions in the applications. you get all the necessary to let the user tune what appears in inside the inside the toolbars, which are managed by the GUI window and so on. It's really cool. All right, so here is one integration beastie which is in there. So KXmlGui as inside this class, which is actually, I think, not exposed to the outside. So that's internal. Okay, that's an important part. And in there, we enforce some rule, which is you don't want to have two actions with the same shortcut, right? That would be a problem, because if you have two actions with the same shortcut, then it's ambiguous, and basically by default, Qt just don't fire up. You press the shortcut, and then nothing happens, if I remember correctly. And so we have a KActionConfig detector in there, which is inheriting from KWidget. And you remember when I was mentioning event filters earlier? That is an event filter. And that event filter, we actually set it on the application object. So we see all events for any object. And so in the event filter, we are checking if that event type is a change of shortcut, okay? And if the event, which is supposed to receive that change of shortcut, is an action. If that's the case, okay, we check, because Qt knows from the event, if the new shortcut is actually ambiguous. So that means if that's ambiguous, that means another action has the same one. So if it's ambiguous, then we display a message to the user to say, it's ambiguous and so on, and then we filter the event, so it's not set, so the new shortcut is not set, and the user knows about it. If you want to have that feature, then you will need to install the event filter. Remember when I mentioned the application hooks? Well, that's what we're seeing here. We don't provide KActionConfig detector as API because we inject it as soon as you depend on KXmlGui. So we have a function, again, not exposed, which gets a pointer to the application object and install the event filter, a new event filter, which is KActionConfig detector on the app, okay? If we go through that function, then we're fine, the feature is installed. To make sure it happens, we use that macro, which is startup function, the function, okay? And so that means that at runtime, if you link again KXmlGui, just by linking, you don't even need to use any particular API in there, okay? Just by linking to it, you get the ambiguous detection for free, okay? You don't have anything else to do. So this 0 line of code to write on your end, apart from saying, I want to link again that one, okay? Yep. And the trick is, so I remember I mentioned the integration points. I said at some point we will have a KPlatform theme plugin. What did we do is that our KPlatform theme plugin links against KXmlGui. So that means that if you have that plugin installed in the system, and that's the one loaded, any application using Qt will get the feature for free. Okay, so that's one of those cases where we are building something which is very high. Okay, that's in tier 3. And then we manage to inject that feature in any Qt application just by going under with the platform theme plugin. All right, tier 3 again, important one for different reasons. That's KIO, which provide the network transparent access to files and data. And it also allows to launch applications, open files. All of its API is asynchronous via jobs. And then it's extended via a plugin system, which allows to implement the different protocols. File, HTTP, SMB, yada, yada. You can do that for regular protocols. You can also make virtual file systems too. So the trash can is actually a virtual view on how it's actually stored. That's a virtual file system. The timeline, to see a timeline of the different files you touched, that's actually the same thing. The desktop view, same thing. We also have one which is, so you got that tree of applications in your start menu. You can actually see that if you go to applications column slash, you can see that same tree from within Dolphin if you have that particular protocol installed. And the last one is audio CD. So audio CD is getting out of fashion, but if you have your music on compact discs still, you can actually plug them, put them into a drive, gets displayed, and then you can have a view of the different tracks on that CD. And that's very cool because we, even on that virtual one, have subfolders for the different codecs that you might want for it. And then you see the files, and then you just copy them into a folder, and then it will rip and encode the CD for you. Many of those workers, though, I mentioned them, but many of those workers are in KIO Extra. KIO, how to use it in your applications. You need to have jobs. You need to list a directory, for instance. Then you go to the KIO namespace, and there's a listdir function there. Basically, that's how you create the job. Okay, you got a bunch of namespace level functions in there. Say, I want to list a dir which is at that URL, so that could be any URL, right? That could be a file or audio CD or SMB, so something on a Samba server or anything. Your application don't need to know that. That URL might have been passed by the user, actually. You get a job, and that job has a signal entries where you see all the entries as they are being listed. That's inheriting from KJob, unsurprisingly, so there's the result signal as well. So you would want to plug to that, okay, to say, okay, I want to handle the error, for instance, and then display something. And then you get, so for the entries, you could process them. So here we just display them, but you could imagine like displaying them in the list view or something like that. The KIO job subclasses are auto start, so you don't need to call start on them like I did earlier on for another KJob. Those ones, you just create them, and then they will get started when you get back to the event loop at some point. Also, if you link against KWidgets, automatically they get some extra features. By default, they get a UI delegate. You don't have to set it yourself, just because you link to KWidgets. By default, they get a job tracker just because you link to KWidgets. Okay, so in your application code, you don't need to do all that wiring yourself. And for the job tracker wiring, it's even a bit smart. That is, it will dynamically choose a widget job tracker or UI server job tracker depending if you're in a Plasma session or not. Okay, it will make the decision for you. Unsurprisingly, how do we do that? Same thing, we're using, so in that case, that's called a KConstructor function. That's pretty much similar to what we've seen before. We call register job UI delegate, which is private, you don't see it. And then we will register the right UI delegate factory and right extensions. We have lots of different jobs. Okay, I just show list here, but there's everything you need to copy files and so on. Okay, there's also plenty of widgets in KIO, and pretty much everything you would need to navigate the file systems, virtual or real or on the network, you get that in KIO. This is one of the biggest frameworks we have. Okay, so make sure to check the API documentation. I can't do it justice with just a few minutes I gave it right now. Now for tier 4, this one provides mostly no API. It's mainly here to tie the pieces together. So remember, I went quickly over it, but I mentioned that we had KMessageBox, which have the don't ask again feature, but it's tier 1. And also in the tier 1, we have KConfig. So one thing would be, well, if that's tier 1, it cannot depend on KConfig to provide the feature. No, it can't, because both of them are tier 1, but we're cheating somewhat. What we are doing is that inside of the framework containing KMessageBox, we have a KMessageBox don't ask again interface, which provide a bunch of methods, okay? So pure interface, they're all pure virtual. And the don't show again name, that's the one which is passed to KMessageBox or KMessageDialog. And so the framework integration plugin, which is in tier 4, will provide an implementation for that one. So you're depending on something which is tier 1, but if the framework integration plugin is there, that thing which is in tier 1 will try to load that plugin, it will find it, and through that plugin, the implementations which are for that interface are actually going through another tier 1. So that's how we manage, okay, at build time to have both tier 1. They're independent of each other. We have a fallback mechanism if KConfig is not there and the plugin is not there. But if both of them are here, then you get extra feature, even though that was tier 1. We have a similar trick for KMessageBox and KNotification. So we have a KMessageBox notify interface where we try to send a notification. If KNotification is not there, then you don't get that, okay? All right, there's more things about KStyle, but I purposefully skipped it earlier, so I would just keep that. All right. That was a very quick and biased tour, obviously, okay? Again, go to the API documentation, you would find many more. I try to focus on points which would either give a feel of how many features it has, or would ensure that we would see some of the lesser obvious integration points, like the one we've just seen with MessageBox right now. The tier is purely about the build dependencies and how things are linking to each other, okay? So if I got something which is tier 1, it depends only on Qt and system libraries. Tier 2 depends on tier 1 and whatever tier 1 depends on. Tier 3 depends on basically anything, anything under or in tier 3. Now, what N-P was getting into was the type. And so for the type, it is correct that we have functional and integration. And I see he's typing again, so we'll see if he gets the third one. Sorry. Okay. Yeah, I derailed you and you didn't finish. But so you got functional. In that case, there's no runtime dependency. That's what this is about. Just no runtime dependency. Everything is determined at build time, okay? Integration, you have optional runtime dependencies when you're trying to integrate with a platform. That's why Sonnet was probably not the best example. And then solution, that is, you have runtime dependencies. That's for software architecture reasons. So good example of what would be in solutions would be Akonadi, KIO, okay, KIO, or you got the workers, which are actually in another process that's on purpose, right? They are picked by plugins, that's on purpose, that's what provides the actual value of the solution. For integration, you would have something like Solid, which would be like an obvious one, where you have some runtime dependencies on new disk or something like that, because you need to integrate with the system. On some other platform, you might use like a system API instead directly, and you have no runtime dependency. All right, which mechanism do we use for lower tier frameworks to benefit from features of higher tier frameworks? Dependency injection, yes. More specifically, we're using basically hidden plugins for that, right? We have the interface, then we need a plugin to actually provide that feature. Which mechanism do we use to inject behavior in a Qt app which uses a KDE framework? Yeah, that's where our application hooks become important, right? And just by linking, we can emphasize those, which is a nice thing for us. Which type do we use for asynchronous operations generally? Well, at least the one we've seen from the frameworks. Yes, if I want to do something, so NMySP proposed KIO job, that's correct. If I'm using KIO because I want the network transparency for access to file, but more generally, if I'm making my own application and I want to describe an asynchronous operation, what would I inherit from? KJob, yeah. And all the KIO jobs, they inherit from KJob. So if I need network transparent operations, which framework do I use? Then everyone should be shouting KIO by now. And if I need to distribute scripted content for my application, which frameworks do I use? It's a bit random, that one is. Quickly went through it, KPackage. Yeah. All right, key takeaways from that very, very quick section. The tier of a framework is about its link time dependencies, complexity. The type of a framework is the mix of the amount of runtime dependencies and the intended role of the framework. There's pretty much a framework for KDE Frameworks for KDE Framework for anything. For sure, all the common tasks needed to build lots of different types of applications are covered. So if you have a Qt application today, maybe look at some of the frameworks. We have hidden plugins to inject features in frameworks behind the scene, and we use the application object hooks to inject framework behavior from a framework into an application, which simply links to it. All right, now KDE Plasma, and should I give you 5 more minutes because we're past the 2 hours mark? All right, I will give you 5 minutes again. Oh, I've been good this time. We are 20 again, so let's 20 past. So let's start again at 25 past. Same thing than earlier. If you have any questions, please shoot them here. Let's continue. So now we covered frameworks. Okay, we've seen some of the integration points between the frameworks. Now it's time we go one level on top and we actually start talking about Plasma, and we're more than 2 hours in. Why is that not switching slides anymore? Ah, there it is. So objective of this section, and I will probably skip some more content so that we don't finish too late, depending on the time zone you're in. Objective, we want to introduce LibPlasma, and how we go from LibPlasma to actually building an environment for the user. To have an idea also of the important components distributed in workspaces, because there's plenty actually, and how to understand how we re-inject behavior in all the Qt applications from the Plasma environment. We also want to have a rough idea of how KWin is structured and how it differs between X11 and Wayland, and to know how to extend system settings. Out of all those objectives, the last two are probably the ones I would have to leave on the side for today. We'll see how far we go, and depending on the energy of everyone. So LibPlasma. LibPlasma, as I mentioned, Plasma was here before Qt Quick. So it's not really something about Qt Quick at its core. At its core, it was designed to be a component model for workspaces. So it basically revolves around the 3 types that we have on the screen. So you have Plasma Corona. Remember, that was before the pandemic started, right? So Plasma Corona, that's like the crown, right? Represents the whole workspace or the scene. That's the one which defines the basic rules of the workspace, including the overall layout. It will be the one which manages the containments in a screen and activity-aware fashion. this is also the one which will control if we're in edit mode or not. Plasma containment represent areas within the corona. So that's the one which allow to say, okay, that's the back of my screen, right? The wallpaper and so on. That's a containment. The bar where you have your virtual desktops and your tasks and the sys-tray and so on, that's a containment as well, okay? So they can be basically desktop or panel. There's a few more types, but we will ignore them here. Some of them are for mobile use, actually. All of those, okay, so the corona, the containment, they are form factor, the containments, they are form factor and activity aware. Plasma applet represents a widget. Sometimes we call them plasmoids as well. So that's actual feature that the user can interact with. Applets, they provide the actual behavior, the interactions. They are also form factor aware. Interestingly, if you look here, containments are applets, right? So they contain containments contain applets, but they are themselves are also applets, okay? And the last one, which doesn't show here, is Plasma theme. That's the one which provides all the theming information to other classes like containment and applets. So the color scheme to use, the fonts where to load the images from, and so on. They're all loaded using KPackage. The C++ API is mainly here to develop your shell. The packages are all QML based. This library also comes with a set of items to use on the QML side. So there's two important modules there, which are all KDE Plasma core, which provides a convenience to load SVGs from a theme, and that includes caching, the coloring, rendering of sub-elements, and so on. So all the theming is basically running on that. And all the KDE.plasma.components, which provides Qt controls 2 implementations backed by SVG-based primitive, because everything is SVG-based in all shells. Applet authors should actually use elements coming from those modules, because that's how they will ensure a coherent look and feel for their applet on a given desktop, a given workspace, sorry. One thing to keep in mind, we are talking here about the KDE Workspaces, okay, plural, because to build workspaces, you need to provide services for the workspace you're trying to build, so application management, hardware interaction, system status. You need to provide also lots of configuration modules and how to navigate them, so that would be system settings, styles covering the whole session. And if you want to cover the whole session, you go from Grub for the bootloader, then Plymouth for the boot splash, then SDDM for the login management, then the theme for Plasma itself, the theme for widget-based applications, the theme for Qt control space applications, excuse me, and the theme for GTK. So there's lots of themes. And they all need to be coordinated. You don't want something to look foreign compared to the other ones. You need to also provide the features for the users, and that will be provided by applets. You need to provide a shell, a window manager to tie it all up together, and the integration plugins. Remember, we started to mention integration plugins in the previous section because of the integration points between KDE Frameworks and Qt. In that list, even though that's a fairly long list, none of that says desktop, right? So you have to multiply that for each form factor, which you support. That would be mainly shell and containments. And thanks to our technology, the rest mostly applies on all form factors, okay? We don't have lots of money, so we have to be clever. And so we try to be clever by having technology which can be reused and adapted on various form factors as much as possible. All right, so let's get back to Q platform abstraction, okay? So I mentioned we shipped a QPA plugin. I just mentioned it in passing. So now it's time to look more into it and see what else it does. I just mentioned it links on XMLGui basically so far, right? But why do we have it in the first place? So a reminder, we have two levels of plugins, okay, KPlatform integration and then KPlatform theme, which creates plenty of different stuff. We don't want to redo all the work for X11 or Wayland, okay, so that would be at that level. And so that's why we work at this level. And so here is the trick. KPlatform theme, let's get back to it. So I said, you have a KGUI application, okay, so that's what you create from your main. When it will be kickstarted, it will create the KPlatform integration via a plugin. On that plugin, it will call theme names. Okay, it will get a list of names. If it doesn't find a platform theme under that name, then it calls on the same. It calls create platform theme, which will internally create a KPlatform theme shipped with Qt. Now, if it finds a plugin, a platform theme plugin under the name, then it will skip that step, yeah, and it will create the platform theme straight from the plugin. That's where Plasma lives, okay? We will ship a QPA for Plasma, okay? So we'll skip all of that, and that will create for the platform theme, okay? So we'll create our platform theme coming from our plugin. And so we have Plasma integration. It will provide our KDE platform theme. This one will link against a bunch of KDE frameworks, KIO, KConfig, KNotifications, KIcon themes, and more, okay, including XMLGui, which I mentioned earlier. And remember that just by linking to those from the plugin, there's a lot of dark magic we can actually do, okay? And we don't shy away from it. So features, this enables integration of the menu bars with our global menu. That's coming from that platform theme. Integration of the system tray icons with case, status, notifier, item, protocol, specific protocol that we're using nowadays. That's done this way. Overriding the file dialog with our own implementation. We do that from there. Replacing the stock KUicon engine with our own KIcon engine, which respects the user theme, which provides inter-process caching. That's done through the platform theme. Overriding the default key bindings based on the standard shortcuts by the user. We do that as well. Injecting the default palette for the from the settings. Done. Forcing our own Qt controls to theme. Done as well. Okay, so that's all the thing we enable just because under Plasma Workspace, it's picking the right platform theme. That's basically everything you need to make a Qt application look native in Plasma, okay? Plasma itself, this is where we provide the implementation for the containment and applets. So desktop form factor, we provide desktop and panel containments. For the phone form factor, we provide home screen, panel, task panel containments. We don't want to re-implement the shell using C++ for each shells. So we used to have like a Plasma desktop implementation, a Plasma mobile implementation as C++. Nowadays, we have only one shell implementation, which is named Plasma Shell, which has its own Corona subclass, which is Shell Corona. And the thing it does is that it loads its own package formats. And in particular, it has a shell package, which will control how the user can interact with the applets, the GUI, which is displayed for the settings of containment and applets, the look of the widget explorer, default layout, on first start, etc. We also have layout templates, which allow to pre-fill containments in the shell. And that's how we provide the default panel, for instance. All of that is JavaScript and QML based. Okay, so we moved from having several subclass of Corona for each type of workspace, and so that would be written in C++ and so on, right, to having only one implementation, which is completely script-driven. Now for Quinn. That's our window manager and our compositor. Okay, it works on top of X11, sorry, or Wayland, and historically it was X11 only. That still shows a bit in the code. The transition is clearly ongoing. And we can have a very high-level view to it. Okay, that's just to give you a rough idea. The situation clearly is more complicated in the workspace area. That's where we have something which is way more in transition. And there can be different code paths being used depending on the platform. It's not a good talk about KWin, okay? It's just to give you a good idea about that. There's very good documentation about it. But one way to see it is that KWin will create a platform object, okay, and will create workspace and client objects depending on, so clients, that's basically the different windows which are on the workspace, and workspace, that's all the virtual desktops that you get, okay? So it will create this in every cases. Now, if it's in X11 mode, that platform, okay, that's just an interface, and so that's the X11 implementation of that platform which will be created. This one will talk to an X11 server, which will talk to the kernel. Now, if we're in Wayland mode, that platform, okay, will actually have an implementation which is DRM based, and that will talk directly to the kernel, okay? There's a few more implementations, but you get the idea. In the case of the Wayland mode, there's no X11 server equivalent. We are also the equivalent of the X11 server. So it also creates a Wayland server to be able to be notified of new Wayland clients coming up and so on. Very, very high level view, again, very simplified here. Focus on Wayland. There's the whole protocol thing which is important for Wayland. So there's a bunch of XML files which describe the Wayland protocols. They are going through Qt Wayland Scanner, which is provided by Qt directly. And that generates a bunch of C++ code, which will then be used on KWidgetsAddons, K-Windows System, K-Idle Time, or we also have K-Wayland. They all try to talk to compositor. So in our case, that would be KWin Wayland. The Qt Wayland QPA will also talk to KWin Wayland, okay? And KWin Wayland internally uses K-Wayland, okay? So then we have this kind of weird dependency here that's not just used for the same thing. Those protocol files, they will come from Wayland protocols, so that's all the standardized protocols, or Plasma Wayland protocols, which are protocols specific for integrating an application on Wayland. Yeah, I know it doesn't reuse K-Wayland, that's phased out. It used to, but yeah, less and less. Yeah, and so you have to remember that KWin is a Wayland server implementation as well. All right, last one, so that will be system settings in here. And so the question is, where do the configuration GUIs come from for system settings? That's actually a simple recipe nowadays. You remember I mentioned KConfigXT. So you create a KConfigXT file representing your settings. You slap some GUI on top of it. You have mostly two cases, KWidgets based, and then you would inherit from KCMUtils. We don't do that anymore. I mean, we don't make new KCMUtils for system uses going by KWidgets. So otherwise you will start with Qt based. You inherit from KQuick-Addons manage config module. And then you bundle the QML-based GUI code that you need as a Qt resource, everything in the library, in the plugin for that. And the root of the QML script will have to be a simple KCM or a grid view KCM. Plasma workspaces, as I said, have only QML-based KCMs nowadays because they're more Plasma mobile friendly. Remember, we try to be smart about that, right? And it is good form to also provide a KC module data for your plugin, because if you don't do that, then the highlight change settings feature is basically blind to your module. And we hope that KC module data will open the door to other features later on, like a better way to search for settings from system settings. All right, key takeaways from that chapter. The workspaces, they essentially provide system services, configuration modules, styles, applets, integration plugins, a shell, and a window manager. This is largely form factor agnostic. And it's all written in a way that we try to maximize reusability, because again, we are not a big corporation. We cannot afford making GUI several times for different form factors. For that, we rely quite a bit on scripting and KPackage. Our KDE platform theme for QPA is key to integrate Qt applications in our workspaces properly. KWin has its own platform abstraction layer that we've seen, right? The platform, and then you got the DRM and so on. KWin is also a Wayland server implementation, and the system settings API is mostly provided by KDE Frameworks. So what did we do today? We had a first look. We first took a look back at the Qt KDE history. We also identified some of the key technologies which go way back in the past, right? We were in the 90s. We better understand the event loop and the Qt platform abstraction for our context. We've seen the typical patterns which are used in KWidgets and Qt Quick applications and how they impact reusability in our stack. We also explained how KDE Frameworks is structured as a product, right, with the maturation model which I mentioned. We also confirmed that there are an almost infinite amount of features available in there. We explored some of the shady secrets we use for both having splitted frameworks and a coherent experience when it's all used together. So remember those hidden plugins that we have. We listed what we have in our workspaces. We focused on how Plasma ensures Qt applications integrate with the workspace properly, so the whole Plasma integration discussion we had, and we also got a quick look, very quick look at how KWin is structured, especially on Wayland. We didn't have labs. That's kind of unfortunate, but yeah, I think when I will get to split it, I will actually have labs at least for one of the two. And also, if we want to go through the KDE Framework section, if we don't go through everything, we will need days to go through it. All right, that's everything I had in store for today. We're slightly under the 3 hours mark. I hope you enjoyed that. If you have further questions, feel free to ask. And I hope that you enjoyed this session as much as I actually enjoyed giving it, and that you learned a thing or two. All right, so I got one question from Bernardo. Do event loops work without a Q application? Pretty much no. By the way, when you say Q application, I guess you mean Q star application, right? A Q core application, or a Q GUI application, or Q application, right? But yeah, you pretty much need to have one. Yeah, that's what we've seen, right? You get because the application, the GUI application, for instance, would be the one creating the QPA and so on, which will create the event dispatcher. You get a different event dispatcher if that's a Q-core application, right? But that's the application object doing that. And then, if you remember, the event dispatcher only pulls on the sources, but then calls dispatch on the. So you need the application object, right, to be there. Does KXmlGui create application layout at all, or is it more for settings, keyboard shortcuts? No, you're correct. Maybe I glanced that over a bit too much. But if you're using something like KXmlGui window, it kind of forces your hand on the fact that where things will be placed. So things are lazily created, But if you ask a status bar, it will create one for you, but it will always be a status bar properly placed, right? If you want to have palettes, that's pretty much freeform. The toolbars will already, they will be created. Users can change them, but by default, you get them at the top. And then you get the API to have a central widget, right, which would be your attention. So that kind of forced to have this model of, header, central widget, footer, and then that's a QMain window, right? So you get a whole system palettes, the whole system of palettes, panels that you can move around, and the toolbars can be moved around. But by default, I think nowadays by default we lock them in place, but the user can go unlock them and then move them around. It kind of forces you in the sense that you have that central widget concept. At the same time, the user can unplug things and adapt it to their preferences. So someone asked if I mind sharing a link to the documentation APIs for KDE Frameworks. So that would be api.kde.org/frameworks, basically. We've got some more APIs. They're not necessarily inside of frameworks or inside of frameworks yet, like the KDE PIM ones. So we have several sections. Right, and we also have developed at KDE.org. Yeah. KUnitConversion base K parts. No. Well, not that I'm aware of, at least, but maybe Nicolas knows more about that, but I'm not aware of any plans in that regard. Yeah, nothing concrete yet. We'd like it, for sure, but there's nothing concrete. At that point, I think that wouldn't be easy to get there. That's definitely something we like, but it's very, very much tied to widgets. Last I checked, so there would be some thinking to be done there. But there's, no concrete plans. All right, that's it. Thanks everyone for showing up and taking the time. And again, I hope you enjoyed that. Apparently that was the case for at least a chunk of you. And have a nice evening.